Hello once again. Now we have a problem that is asking us to prove one of the most famous theorems of mathematics, the Pythagorean Theorem. It gives us a right triangle ABC with a hypotenuse equal to lowercase c and legs lowercase b and lowercase a. Part A asks us to prove that a squared is equal to c times d. So that's where we should probably start. Now, if you look at the diagram that it provides, it looks very similar to the last problem we did. So we can use a similar technique to solve our problem. Draw the three triangles that we see in the diagram separately. So the first triangle I'm going to draw is C, D, B. And CB has a length of that lowercase a, and BD has a length of lowercase d. CD has a unspecified length, so I probably shouldn't worry about it right now. Now let's draw the other triangle. We have this triangle, which is going to represent C, D, A. Now this triangle, again CD, we don't really know what the length is, so I'm not going to worry about it, but I know that DA has a length of E, and CA has a length of lowercase b. And then finally we have our big triangle looking like that, with the right angle over here, CBA, with BA has a length of lowercase c, and CA has a length of lowercase b, and CB has a length of lowercase a. Now, let's prove that part A squared is equal to CD. Well, how can I start that? Based on a previous problem, I know that all these triangles must be similar. Therefore, I can create some ratios based on the side lengths. If I have an A as a part of my equation that I'm trying to solve for, then I should probably look for a side that contains the side length lowercase a. Well, I have a couple choices. I have BC over on our first triangle and BC on the third triangle. So let's just pick either one. I'm going to pick BC as our length of A. Now, which side matches up with BC, which I can tell is our hypotenuse since it's opposite to the right angle? Well, in our second triangle, the hypotenuse over here has a length of B. But that is irrelevant for now. If we look at our equation, there is no B in the problem. So I'm not really looking for a B as a part of my equation or my ratios. But if I look over at the third triangle, I notice the hypotenuse has a length of C. So, and I do notice that C is going to be involved in our problem. So A over C would be a good proportion to work with. Now, what other length can I work with in triangle BCD? Well, that lowercase d that represents BD is our only other choice. So I'm going to put lowercase d. And which side would that match up with? Well, the lowercase d represents you could imagine it as like the smaller side of the triangle. So what's the smaller side of the triangle ABC? Well, it'd be this length here. That has a length of A. And now if we cross multiply, we have A times A, which is A squared, equals C times D, which proves part A. So now we can move on to part B. Part B asks for a similar proof, but that being that b squared is equal to CE. Well then, let's try to make a proportion involving b squared. So I'm going to start with some side length that contains b. How about CA in the second triangle? And what side would match up with that? Well, that's the hypotenuse, and the hypotenuse of the triangle, our third triangle, ABC, is lowercase c. So I'm going to put that there. Set that equal to, the only other choice I have for my second triangle is E. And I put that over the corresponding side, which would be B on the other triangle. Again, do cross multiplication, and you will see that we get b squared is equal to CE, which proves part B. So now that we have A and B checked off, let's look at part C. Use the first two parts to show that a squared plus b squared equals c squared. Well, I know what a squared is equal to, and I know what b squared is equal to. So if I add the two together, a squared plus b squared, that is equal to a squared I know is c times d, plus b squared, which is CE. And I notice both terms, CD and CE, have C in them, so I can factor out that C. And I'm left with C times C times D plus E. But what is the length of D plus E? Well, that also, well, if I look at it, D and E put together equal this whole length C. So what this really amounts to is C times C, which is C squared. So I've just proven that a squared plus b squared is equal to c squared, proving the Pythagorean theorem.